Hello everyone. Today I am going to start the new topic in Fourier series, that is even and odd nature of f of x in 0, interval 0, 2 pi and associated Fourier series. We already studied even and odd nature of f of x in the interval minus pi to pi, and this is for in the interval 0, 2 pi. See here what is the definition when the given function is in the interval 0, 2 pi for even and odd. F of x is said to be even if f of 2 pi minus x is equal to f of x, and odd if f of 2 pi minus x is equal to minus f of x. Means when we say the function, this function f of x is even when f of 2 pi minus x is equal to f of x, then it will be even. If f of 2 pi minus x is equal to minus f of x, then the given function f of x is odd. We note that cos x is an even function since cos of 2 pi minus x is what? Cos x. Therefore, it is even. Since sin x is an odd function because sin of 2 pi minus x is minus sin x. Therefore, it is an odd function and this is even function. Here we have two cases. F of x is an even function. When f of x is an even function, the Fourier coefficient with the application of integral property becomes a naught is equal to 2 by pi integration from 0 to pi f of x dx, and an is equal to 2 by pi integration from 0 to pi f of x cos nx dx, and bn is equal to 0. Here formulas are same, but only the difference is when we are checking whether the given function is even or odd, we have to take 2 pi minus x here. In that we are taking x and minus x, and the second case is when the f of x is odd, a naught is equal to 0, an is equal to 0, bn is equal to 2 by pi integration from 0 to pi f of x sin nx dx. Note, if f of x is equal to, means our given function f of x having sub functions like phi of x and psi of x, means f of x is equal to phi of x when x lies between 0 and pi, and f of x is equal to psi of x when x lies between pi and 2 pi. We say that f of x is even if phi of 2 pi minus x is equal to phi of x. When the given function is like this, we have to check the given function is even or odd. If we get f of 2 pi minus x as psi of x, then the given function is even, and if phi of 2 pi minus x will be minus psi of x, it will be odd. Let us see the example. Obtain the Fourier series representation in 0, 2 pi of the function f of x is equal to pi minus x divided by 2. Given function f of x is equal to pi minus x divided by 2 in the interval 0, 2 pi. Now we have to check whether the function is even or odd. For that, f of 2 pi minus x is equal to pi as it is. We have to change x as a 2 pi minus x, 2 pi minus x divided by 2, which is equal to pi minus 2 pi plus x divided by 2, which is equal to minus pi plus x divided by 2. This can be written as, here minus pi plus x divided by 2, I am taking negative common. In these two terms we will get pi minus x divided by 2. See, this is equal to minus f of x. our f of x is pi minus x divided by 2, but we get f of 2 pi minus x as minus pi minus x divided by 2, which is equal to minus f of x. Therefore, f of 2 pi minus x is equal to minus f of x. The given function f of x is odd in the interval 0, 2 pi, and hence a0 is equal to 0, an is equal to 0, and bn is equal to 2 by pi integration from 0 to pi f of x sin nx dx. Okay, now we have to find the bn. Bn is equal to 2 by pi integration from 0 to pi f of x is pi minus x divided by 2 into sin nx dx. Here 1 by 2 is a constant. Take outside the integration. It will be 2 divided by 2 pi integration from 0 to pi minus x sin nx dx. 2 get cancelled. 1 by pi integration from 0 to pi minus x sin nx dx. To solve this one, we have to use the using Bernoulli's rule. Using Bernoulli's rule, we have bn is equal to 1 by pi. While we are using Bernoulli's rule, this is differentiating part. Consider this as differentiating part, this is integrating part, so that keep differentiating part as it is. Integrate this one, cos nx divided by n. Since the integration of sin nx is minus cos nx, therefore it is minus cos nx divided by n, minus, now we differentiate this one. Differentiation of this one is minus 1. Pi is constant. Differentiation of pi is 0, and differentiation of x is 1. Here we have minus, therefore it is minus 1. Then again integrate this one. We get minus, as it is, sin nx divided by n into n is n square. The next term will be 0, because when you differentiate this minus 1, it will be 0. So that stop the process here only. This is 0 to pi, which is equal to 1 by pi minus x minus cos nx divided by n, minus, this is minus into minus, plus sin n x divided by n square, limits from 0 to pi, which is equal to 1 by pi. Now we have to apply the upper limit and lower limit. For that, first apply upper limit and lower limit for this function. First term, it will be, first one is pi minus pi. Apply here. It is a minus cos n pi divided by n. Upper limit is over. Next, minus lower limit is pi minus 0. Cos 0 is 1. Here 1 divided by minus 1, sorry, it is minus 1, because cos n into 0 is 0, cos 0 is 1. Here we have my negative sign, therefore it is minus 1 divided by n. Upper limit is also over. Now go to the second term, minus, we know that sin pi value is 0 and cos pi sin 0 value is also 0. 1 by n square into 0 minus 0, because while we are applying upper limit it will be 0, and when we apply lower limit it is also 0. Therefore 1 by n square into 0 minus 0, which is equal to 1 by pi here pi minus pi means it is 0, 0 into something is 0, minus into minus plus pi by n. Okay, minus 0 is 0, 0 into something is again 0, this is also 0. Okay, remaining is only bn is equal to 1 by pi into pi by n. Pi get cancelled. Bn is equal to 1 by n. Therefore, the Fourier series is f of x is equal to, since a naught is 0, a n is 0, we have only a bn term, so that it is summation n running from 1 to infinity, bn value is 1 by n sin n x. This is the Fourier series. Like that we have to solve the example when the given function is in the interval 0, 2 pi. Difference between the previous and this one is just we have to check whether the given function is even or odd in respect to the intervals. Next example, obtain the Fourier series expansion of the function f of x is equal to x when x lies between 0 and pi, and it is x minus 2 pi when x lies between pi and 2 pi. Hence deduce that pi by 4 is equal to 1 minus 1 by 3 plus 1 by 5 minus and so on. See here our given function having a two subfunctions. We have already seen the one note. In that we are taking this first as a phi of x and this is psi of x. So that I am considering here phi of x as x and psi of x as x minus 2 pi. And this is what Fourier series for the period 2 pi. And in the given f of x is, in f of x, let phi of x is equal to x and psi of x is equal to x minus 2 pi. Now we have to check whether the given function is even or odd. We already know when we say the given function is even and or odd, when the given function is of the form phi of f of x is equal to phi of x when x lies between 0 and pi and psi of x when x lies between pi and 2 pi. No. Phi of 2 pi minus x is equal to, here phi of x is x only, therefore 2 pi minus x, which is equal to, here this is 2 pi minus x. On seeing this result we can't get any conclusion, means whether the given function is even or odd. We know that the given function is even when phi of 2 pi minus x is equal to psi of x, and it is odd when phi of 2 pi minus x is minus psi of x. I will take minus common in this two term. It will be minus 2 pi plus x This can be written as minus of x minus 2 pi. See here, x minus 2 pi. This is same as the function psi of x. Therefore, phi of 2 pi minus x is minus psi of x. Therefore, the function is odd. Therefore, f of x is odd in 0, 2 pi, and hence a0 is equal to 0, ban is equal to 0, and bn is equal to 2 by pi integration from 0 to pi f of x sin nx dx. Now we have to find this integral, means bn is equal to 2 by pi integration from 0 to pi. We have to take the function f of x where x lies between 0 and pi. According to our given example, f of x is equal to x when x lies between 0 and pi, so that f of x value is x into sin nx dx, which is equal to 2 by pi. We have to apply the Bernoulli's rule to find this integral. It will be x into minus cos nx divided by n minus differentiation of this one is 1. Then again integrate this one minus sin nx divided by n square, limits from 0 to pi, which is equal to 2 divided by pi minus x into cos nx divided by n minus into minus plus sin nx divided by n square, limits from 0 to pi. Now we have to apply the limits. See here, when we apply upper limit to second term, it is 0 because sin pi value is 0, and when we apply lower limit to the second term, it will also be 0 because sin 0 value is 0. Therefore, the whole term will be 0 when we apply the limits, and I will take 1 minus 1 by n outside the limits because this is constant. 2 divided by pi n. Just we have to apply the limits for cos x cos n x 0 to pi, which is equal to minus 2 divided by pi into n. Applying first upper limit, pi cos n pi minus 0, because x is 0, 0 into something is also 0, which is equal to minus 2 pi into cos n pi value is minus 1 raised to n divided by pi into n. Pi get cancelled. Then bn is equal to minus 2 into minus 1 raised to n divided by n. See here, this can be written as 2 into minus 1 into minus 1 raised to n divided by n, which is equal to, here bases are same, we have to add the powers, minus 1 raised to n plus 1 divided by n is the bn. Bn is equal to 2 into minus 1 raised to n plus 1 divided by n. Thus, the required Fourier series is f of x is equal to summation n running from 1 to infinity 2 into minus 1 raised to n plus 1 divided by n into sin n x, which is the required Fourier series for the given function. Now we have to deduce their series. To deduce the series, let us put x is equal to pi by 2, then f of x is equal to pi by 2, since f of x is equal to x, or first phi of x is x. Since we know that f of x is x, when we put x as a pi by 2, it will be f of x is equal to pi by 2. Then hence the Fourier series becomes f of x is x and x value is pi by 2, therefore it is pi by 2 is equal to, here 2 is a constant, summation n running from 1 to infinity minus 1 raised to n plus 1 divided by n into sin n pi by 2. After this we have to expand the series. Apply one by one the values of n. When we apply n is equal to 1, it will be minus 1 square, means it is plus 1 divided by n. Sin pi by 2 value is 1. Then apply sin n is equal to 2, it will be minus 1 raised to 2 plus 1, it means it is 3, minus 1 cube means minus 1 divided by 2. Then it is sin 2 pi by 2 means pi 2 get cancelled, sin pi value is 0. Like that you have to expand this series. After expanding and noting that sin 3 pi by 2 means when we apply n as a 3, it will be 3 pi by 2, which is equal to minus 1, and sin 5 pi by 2 is equal to 1. While we are applying the values of n, you get this terms, that is sin 3 pi by 2 and sin 5 by 2 and so on. We know that sin pi by 2 value is 1 and sin 3 pi by 2 value is minus 1. Again sin 5 pi by 2 value is plus 1 and so on. We get, take this 2 here, it will be pi by 4 is equal to 1 minus 1 by 3 plus 1 by 5 minus and so on. This is the required series which we have to reduce here. Like this you have to solve the examples, means to find the Fourier series for the given function when our f of x lies in 0, 2 pi.